Hello everybody, welcome to my new video. This video is going to be about the geomagnetic field that surrounds Earth. And it's the geomagnetic field that surrounds Earth that protects Earth from the sun. Now, the reason that I'm even doing this video is I want to talk about the weakening of the geomagnetic field around Earth and why could that be happening. So first I want to go over what forms the geomagnetic field to begin with, and so we'll look at the Earth's core and stuff, and then go from there we'll look at a few headlines, see what the predictions are, and then I have an idea why our geomagnetic field is weakening. I'm going to show you 3 pages here that have some numbers here that are interesting. Earth is losing its magnetic field, scientists say, whoever they are. But the main thing here is the magnetic field surrounding Earth is weakening. Science say it could be gone in 500 years. That means completely gone. Then they say the result here, which is a total fallacy here, the result, Earth's magnetic poles could literally flip upside down. Well, that's not going to happen if we don't even have any magnetic field. They do give some estimates here. 800,000 years ago was the last time we had the flip. So they're actually talking more about the flip than anything. And then they even go on to say here where the magnetic field has always tended to restore itself. I don't know how they know that, because they've only been measuring this thing for the last 100 years ago. So this really isn't all that great of an article, but still it's a headline. Now they say 500 years up here, but they don't say, well, here we go. The strength of the magnetic field has lessened by 10% in the last 150 years. Well, if it's 10% every 150 years, that means in 1500 years, the magnetic field will be 100% gone. But yet up at the top here, it says that it'll be gone in 500 years. Here's another one. Weakening of Earth's magnetic field has greatly accelerated. Now that's the important part here. Accelerated. They're talking about a sudden pole shift. A sudden pole shift that could potentially cause trillions of dollars in damage. Well, that's not going to happen, because there's not going to be a sudden pole shift. It takes hundreds, probably thousands of years for it to actually shift. Then we move down here to the numbers, and we have up here, previously scientists had told us the magnetic field was weakening by about 5% every 100 years. So that's a different number. But now, new numbers are saying that the Earth's magnetic field is decreasing by approximately 5% per century. Recently, scientists using the Swarm satellite announced their data indicated decay rate 10 times faster at 5% per decade. So at 5% per decade, that's 25% in 50 years. Well, if the geomagnetic field is gone down 25% in 50 years, that's a lot. Because in 100 years, it's going to be 50%. That's very weak. I think at 25 to 50%, we're going to start seeing a lot more of the sun's radiation getting through. If the magnetic field weakens enough, we'll start to lose atmosphere, and then we'll lose the oceans. The atmosphere will get blown off because the magnetic field protects us from the solar wind, which is 1 million mile an hour solar wind of electron particles. So that's not good news at all. But the fact here is that I'm trying to point out is that now it's accelerating. And they've only been keeping records for maybe 100 years, so I don't even know how they can say 150 years to begin with. But let's say it is accelerating. Oh, why would it be accelerating? Well, if we take a look at the core of the Earth, we see that there's an outer core, and the outer core is the molten part. Now, just quickly, this is what causes, this is the actual dynamo for creating the magnetic field, because there's convection, there's currents, the planet is spinning, we've got this hard solid metal inner core which is suspended inside of this, but I can't help think that this core is moving around a little bit too, may get off centered slightly, causing this magnetic field to change or maybe even wander. You think, okay, well, how come it goes from north to south? Well, something in the middle here is causing all of that. But the fact is that this generates the magnetic field around the planet, okay? It's been there for billions of years. I really don't think that in the next 100 years, 500 years, or even 1,000 years, that core is going to be any less melted than it is now. That solidifying of the core takes millions or billions of years. So how could it be that our magnetic field is deteriorating by now up to 5% every 10 years? That's a lot. I mean, after being there for billions of years, all of a sudden. So no, there must be some other factor here. If we do lose the magnetic field, we're going to end up like Mars. No protection from the sun, solar wind blew off the atmosphere, melted all the ice, evaporated the ice and the water that melted from the ice, because Mars used to actually be an ice globe. It never had oceans, but all of the ice on Mars melted, may have formed some pools of water, but basically with no atmosphere to speak of. It's just going to evaporate almost as fast as it melts, okay? There's way more evidence on Mars of melting glaciers or melting ice than there is of a standing ocean. Here's the core of Mars. Right here, the outer core is solid, so there's no dynamo there to create a magnetic field. That's why Mars is dead, and has been dead for about 3 or 4 billion years. So here's Earth's magnetic field. We have the North Magnetic Pole is off from the geographic North Pole, which would be the poles that the Earth spins on its axis. This other magnetic pole is off because it wanders. Quick diagram showing the difference between a healthy planet and a not healthy planet. And also notice that the auroras come in through the top here, through these, and the bottom through these open, like almost open field lines here. That's because this area is getting bombarded from radiation from the sun, and so it reacts and creates this aurora. And also note that these are electrons. Pole flips have been happening from day one. Here is a chart showing the black and white bands right here are the polarities, and the black is where it is now. I'm over here on the upper left here, but you can see there's been a lot of pole flips. I don't know how many, probably at least 1,000. And these are the ones that have been recorded into the rock, and a long ways back too. They've got it all the way back to about 440 million years, and you can see that the Earth didn't look anything like it does now, but the pole flips have been consistent. There's the sea level there, and we'll see that the sea level here, just quick note, is that it has been decreasing and going down for 30 million years, and just lately has started to rise again. Here, the global temperature scale, the orange and blue area there. So we have, the globe has actually been heating. It just seems inconsistent that it's overheating and yet the sea level is down, but the sea level is mostly dependent on how much ice is on the poles, or if there's an ice age or whatever. Here's Saturn's magnetosphere. I got Titan outside of it. Notice it's getting hit with full brunt until it goes around behind Saturn. But this shows that Saturn has a dynamic engine inside of it that's creating this, so it probably has a liquid core. Plasma does have mass, so it can crack. It can do a lot of damage if it hits anything solid, because the temperature of plasma is usually in the millions of degrees, and it is super electrically charged. Here's a shot of the field in action. The sun's coming from, or the rays are coming from the left. And since the sun is spinning, it throws out its emissions in this spiral kind of a pattern here. You can see the planets are lined up. This is the extent of the solar wind, and it has a terminal shock right over here, the heliopause. This is, the whole thing is the heliosphere. Here's Earth. CMEs can go way out here. Then we have bow shock. This also protects us a little bit from some cosmic rays too. We have lots of instruments measuring all this stuff, so that's why I tend to believe that there's probably a pretty good chance that the magnetic field is weakening. Another photo showing the extent of the reach of the sun's rays and the bow shock. Another general diagram showing what's happening here. The temperatures on the sun are in the millions of degrees. The center's about 15 million. Then it gets cooler as it goes towards the outside, but then if you get 2 solar diameters away from the sun, the temperature's up to 20 million degrees. Any plasma leaving the sun will go through that 20 million degree zone. And furthermore, when plasma leaves the sun, it can go up to 6 million miles an hour, whereas the solar wind is only 1 million miles an hour. So here's a typical CME. That is plasma. Now it may not necessarily go out into outer space. A lot of this gets pulled back into the sun too. Another one. Another one. This is probably the most dangerous type here. That could be 1 million miles out. Then we have our spectrum over here. These are all of the different, different wavelengths that are around us all the time. So we're basically getting blasted with everything except the gamma rays, X-rays, ultraviolet. But the rest of us, we're pretty much surrounded by this. So we're building a big blanket of this radiation around us and around the entire planet. One CME blasted 80 billion pounds of energized particles out into space and just barely missed us, traveling at 6 million miles an hour. The blue part here is the ionosphere. It's electrically charged by particles from the sun that hit this outer layer here, and it charges this and energizes this up with electrons. We use this ionosphere to bounce our communications off and then back to Earth, so we can communicate to places on the other side of the globe. Just a picture showing how much the planet has been hazed over. This is not normal. This illustration shows the extent that the radiation can penetrate our atmosphere and which ones hit the bottom. And infrared and visible light go right on through. We do have other particles that do make it partially to the surface. This one shows the UV. We have 4 types of UV here. We get X-rays. So luckily we have an atmosphere. If we don't have an atmosphere, all of this comes straight to the ground. This would be the electromagnetic field from a wire. Here it is working. The waves are in, perpendicular to each other, or the wavelengths, or the waves, I guess, whichever you want to say. Solar activity goes down, cosmic rays go up. So right now we're going through a strong period of cosmic ray fluxes, which makes it very unsafe to be in outer space because there's a super dose of gamma rays out there. Alright, so there's the basic idea of how the geomagnetic field is generated. So the dynamic engine that creates this magnetic field of planet Earth is not going to die out in the next 100 years or the next 1,000 or the next 1,000,000 years. So what could be causing the magnetic field to be weakening, and then what would be accelerating that? Okay, so that's the big question here. So let's look at this photo here. Now, what would happen if you completely covered the entire planet, except from out in the middle of the oceans, I guess, with a blanket of electromagnetic force? And I'm talking about billions and billions of electronic devices, power plants, transmission lines, microwaves, 5G, that could be the final nail there, and satellites aiming, they're directing energy back to the planet, and not to mention all of the transmitting towers, and everything else that is completely covering this planet with electromagnetism. So, could that be why the magnetic field is actually weakening? Because it's not weakening because the Earth is cooling that fast. The Earth isn't going to cool off in 100 years. It's got to be something else. Well, 150 years ago we didn't have really any electronics to speak of. But now they're everywhere, and it's increasing. We've got Wi-Fi's constantly increasing, more and more satellites, 5G, 2.4G. We've got microwaves, microwave towers, cell phone towers, all kinds of communication is going on here, and we're creating an envelope of electromagnetic radiation around us on the surface. So I'm wondering what happens when you put a magnetic field like that, an artificial one, within another magnetic field like the one that surrounds Earth. So we've got the shell inside of another shell of a field. Our electronic advancement is just getting bigger and bigger and bigger, more and more and more. So wouldn't it seem logical then that we are actually dampening our own geomagnetic field by creating another field within? Unfortunately, the field that we're surrounding ourselves with isn't going to protect us from the sun, but it is weakening the overall geomagnetic field. This is what I think, because it's the only logical conclusion. The measurements have been taken. The field is getting weaker. Our advanced civilization here has chosen the route to go into this electronic future, which might not be the smartest thing to do because, you know, like I said, we could be dampening the only electric field that is protecting our planet. Now, if we were to disappear, this electromagnetic field around the planet should, quote unquote, repair itself. It'll just get strong. It'll probably get strong instantly without the external, forces acting on it. So if the field is weakening 5% every 10 years, we haven't got much time left. And it won't be long before we start to see the effects of the weakening field, because we'll start getting cancer and all those rays that I just showed you that are going through the atmosphere. There's going to be even more of those coming through the atmosphere, and if the field weakens, we'll start to lose atmosphere just from the solar wind alone, which will eventually take its toll. I don't know how long it takes to evaporate all the oceans on the planet, because we do have an awful lot of water here. But once it's gone, it's not coming back. So that's really scary. I mean, if you ask me, I would say that our technology here is like a slow kill. Eventually, if it does weaken the field, then that'll get us. Otherwise, we're causing our own health problems by surrounding ourselves with these electromagnetic toys. A typical apartment complex. Everybody's got the Wi-Fi. So you're not just getting hit by your own, you're getting hit by theirs and everything else around you. The towers that are all up on top of that building, you're getting hit by everything. So if our magnetic field weakens, we're going to be getting hit with a lot more CMEs, these coronal mass ejections of this supercharged, super hot gobs, they call them blobs actually, of plasma. Looks similar to what you saw coming from the sun. It makes it all the way to here. It can blast a hole right through the atmosphere, but if there's no magnetic shield out there to help stop it, it'll just go right on through. And this is the kind of damage you see. It literally just melts rocks with a super hot blast that only really lasts a few seconds. It doesn't go on for a long time. You can see the surface of that rock has melted, and it really got super hot over here. Here's that same building. Can't remember where that is. Could be Syria. Another almost looks like a plasma blast down at the bottom there. Just the blackness of the rocks there. Some obviously just turned black. They got so hot they were just cooked. So what kind of heat would do that? Well, it's not a comet. It's got to be plasma from the sun. It's the only thing that can be. One side is completely destroyed, the other side is pristine. The rock was just melted right in place. Here's a real good example where this is a molten gash right here. All of this black area of the rock was literally melted. This rock, notice, is sticking out a little more than that, so it must have come from an angle, just outside that wall. Here's a little bit of a close-up. You can see that is just completely melted. Even the middle of that gash is totally smooth. Another view of the melted rock. That temperature of the plasma, like I said, is in millions of degrees. This is even after passing through the atmosphere. It hits whatever, and in this case it hit what I think this is granite, I'm not sure, but it melted it just right on the surface. It's so hot, it only takes a few seconds to do this. Look how smooth it is too. Totally just melted. This is Egypt. Looks like it just literally changed the composition of the rock. This is not heat damage from just laying around in the desert. This I'm not sure. I think it really did get so hot that it actually got glass beads formed there. So in summary, I just want to say that I don't think that the Earth's core is changing enough that the magnetic field is weakening that fast. If it's deteriorating, and it must be, with all those instruments, they couldn't all be lying, then what could be causing that? Are they measuring the field in the wrong places? Not with all those instruments, I don't think. I don't think the core is solidifying. So it can only be that we have created an artificial magnetic field on the surface with all of our electronic devices of every kind, from the biggest to the smallest, but they add up, billions of devices and machines, transmission lines, power of any kind, Wi-Fi, 5G will be the big one. That's the one we'll see what happens there. But with $15 trillion profits to be made, it doesn't matter if it's going to hurt us or not. They're going to go for it. So if our technology is increasing and the geomagnetic field is decreasing, I think that pretty much says it all. That we're not going anywhere. Sooner or later, something's going to come to a head here, because you can't just immerse yourselves in these electromagnetic fields and not have any consequences. So you saw the numbers where the weakening was increasing. It was accelerating. So if you go back 100 years and see how we have accelerated our use of these electronic devices, the more we have, the weaker the field gets. It's the only thing that makes any sense to me. So if it was 5% every 10 years and it's accelerating, it's going to be 5% every 5 years. So in 50 years, it'll probably be all over. So you make up your own mind. Those are the facts as I see them. And it doesn't look good. And then you add up all the other ways that we can go. We got the nuclear wars and all the radiation from all the reactors. Yeah. So I don't know. It just doesn't looking good here. But I think that magnetic field is probably the most important thing. But what are you going to do? Just shut everything down? That's not going to work. We're on a suicide run here, because there's no way to stop it. And then it's just like the fossil fuels. Get locked into that. We have to keep doing the fossil fuel thing. Not to mention the geoengineering and several other ways that we're hurting the planet. I don't know, man. I just wonder if humans really deserve to even live on this planet. It's just too nice, or at least it was. Can't see stars at night anymore hardly. The sky isn't blue. The sun goes down, but it doesn't get dark. So tell me what you think below. Don't be shy. Have a good day. Thanks for stopping by.